welcome everybody. Thanks to being here for my talks. Today I'm going to talk about a tool named KiCad to build PCBs and electronic schematics. And in the same time, I'm going to show you how to build a Shitty Add-On for your electronic badge. So I guess it's the best way to learn how to use the tool. This is who am I? I was a firefighter in France, and I moved recently, 4 years ago in Montreal. I'm doing pen testing there. I'm a speaker, doing some live streaming on Twitch where I'm building those PCBs sometimes. And yeah. So that's the menu. I'm going to talk about KiCad, if you don't know what's a Shitty Add-On or simple add-on now, I think we call them like this, more professional. How to build that with KiCad, and then some bonus and questions. First, let's talk about KiCad. KiCad, I don't know how to pronounce that. So it's open source. It's used to design electronics, schematics. There is a PCB layout, so you could see you can design complex multi-layer PCB using that tool. There is no premium or light version. You have everything you need with the tool, so that's pretty cool. There is a 3D visualization feature, so you could see the 3D model of your PCB. So that's also pretty useful if you want to check the scale and stuff. There is a SPICE simulator, so it's going to analyze the circuit behavior and tell you if there is something that's missing, if you have, for example, a voltage issue, or if you forgot to plug a wire somewhere. And the cool thing is that you have a lot of component libraries that are already integrated with the tool, but the community can build those components, and also you can build your own custom libraries, like 3D model, schematics, and stuff. So I'm mainly going to focus on the version 9 on KiCad. The way it works, you just need to create a project. And in this project, you will have two major files. The first one on the top is the PCB Editor. So that's the one who is going to hold the PCB 3D model of the schematics. And then you have the Schematic Editor, the one below. It's going to hold the electrical schematics design and stuff. I'm going to briefly talk about what's a SAO. So an SAO, let's say, it's like a shiny stuff that's going to blink, that's going to plug onto a badge that's going to blink. So it's just to add more blink into the badge. And there is a standard for this. So it's a 2x3 connector. So the way it works, you have an host badge like this one, and you have the female connector that's going to be plugged there. And simply you have your Shitty Add-On and just going to plug it on the host badge. So the host badge is going to power the Shitty Add-On. It's cool because you can just build the Shitty Add-On that you want, basically. And I've seen some electronic badge that you have the host page, and sometimes you plug a Shitty Add-On that's going to add a feature to the page. So that's pretty cool. So those are some Shitty Add-On I built. This is the first one I tried. I had a lot of issue, prototypes and stuff. And this is the badge from NorSec. So yeah, this one is just going to have 2 LEDs, and yeah, I have put a QR code. It's like a business card. I have some here if you want to grab some at the end. Okay, so we are going to build a Shitty Add-On with KiCad. But first, there is some limitation about the color, depending of the factory you are going to print those PCB. You kind of limit it for 5 colors. So this is how simple PCB is looking. So you have the core substrate. If you look at the picture, it's not very clear, but it's the one that is kind of yellow in the middle. So that means you only have the core here exposed. So you can count that as a color if you want to do some nice design. Then on top you have the layer, copper layer. So this is the shiny copper, the second one. And if you want, you can add on top of the copper a solder mask. So you can see, for example, on the red and the yellow, the red, more like shiny red, is the one with the copper below. And the one around is the one, just the solder mask and the substrate, no copper. And you can have silk screen. You have some colors with that, mostly black and white. On the PCB, if you open the computer, you will see some labels, text. They mostly use silk screen to type those labels on the PCB. But you can use that for doing some design also. Okay, before starting also, maybe you need to think of, okay, what I want to add on that Shitty Add-on. So do you want to go surface mount? So that means, like those I have, you are going to solder the component directly onto the PCB, so there is no hole. Or you can go with through hole, so you will have hole and you can like insert the component and then solder on the back. How much LEDs, what kind of circuit you're going to have, series or parallel. As you can see, depending of the schematics, you will need maybe more batteries or less batteries. And maybe you have other component in mind, like microcontroller, I don't know, 555 timer, something like that, if you want to make the LEDs blink. So all of that is going to be important to think about that before building the actual schematics and PCB. So I went to build a design that matched the theme of that event. So for that, you will need to have a SVG file because you have multiple layers. It's important because on KiCad, you are going to add the layers one by one because each layer are not going to be the same. For example, one will be only copper, the only one will be only the mask or the cutting edge. So you need to import them one by one. So by the simplest ways I found, it's just to use Inkscape. It's free open source also. And I just build the SVG and like so, with multiple layers. Once you have your design in mind, you can start building the schematics. This is a simple one. We have a resistor, LED, and the Shitty Add-on connector, the male one, so it's a 2x3. This one is surface mount. There is no hole. Important to know that the first pin is going to be the. I'm going to talk about that after. For now, it's just the symbol. Okay, it's just to have a visualization about your schematics. And then, yeah. So then you can start building the schematics, adding wires. So make sure that to read the component documentation. For example, the LED has a plus and minus part, so make sure to plug that like great, in a good way. The one is going to be powered by the voltage, and the 2 is going to be the ground into the Shitty Add-on connector. And yeah, make sure that it's easy to understand, because if something is not working, you are going to read that document a lot. So you can add labels and text. So those are not going to be shown into the PCB. It's just like a plan for your schematics. Once you have the schematics, you then need to add footprints to the component. So you have a lot of libraries for each kind of component: sensor, audio, resistor. So here I'm just going to assign for example, the LED. I'm going to assign that LED a specific footprints. For example, this LED is going to be that size, surface mount. So I know then later if I want to order an LED and to solder that one, I know that it's that reference to this LED. So I'm doing the same with the SAO connector and the resistor. And here you can import community libraries and create your own libraries also. Then, once the schematics and the footprints are done, we can start to open the PCB editor and import the schematics into the PCB editor. So it's going to look like this. You have the first on top is the connector, then we have the LED and the resistor. And then you have the option to show the 3D model of each component. It's going to be useful because maybe you messed up the footprints and it's not the right LED that you want to use. And if you have the 3D model, you could like see if there is something that's not working together. So then I'm going to import only the outside of the SVG, not with the logo. And I'm going to assign the outside as an edge cut. So it's going to cut everything else and take the shape and be shown as the actual board, the PCB. Once it's done, you can just place the component where you want. So as you can see, there is like a blue components and red ones. The red are the one that's going to be shown on top of the PCB, and the blue ones are on the back there. So it's pretty useful with KiCad because you can see some blue lines. So it's going to show you the schematics and which connection, where to plug what. So it's going to help you on the next phase, adding wires and vials. The vials are the little holes that you see sometimes on the PCB. They help to go past the wire from the back to the front, or to the front to the back. So as you can see here, or maybe you can't very see that, I'm on the front, so I'm putting a wire here, a vials, and then it's going to go through the back and connect to the resistor. And yeah, make sure to plug everything. Don't forget, yeah. And okay, so that's the final design. So you can add the rest of the SVG. So as you can see, they have different colors because I'm not using the same layers for each one of them. For example, the Wild West's logo is going to be like only copper. Then the mountains, the snow is going to be the silk screen, and so on. So that's why it's important to have multi-layer SVG, so you can import them one by one and choose each layer at a time. Once it's done, you can just export the Gerber files for fabrication. So yeah, just go onto the files and export Gerbers and store those into an archive like a zip file. And once it's done, you can just import that zip file to any factories. Mostly they are located in China. This is an example with PCBWay, so I just import my zip file. It's going to show me that the actual PCB. Then I can choose the solder mask color, green, red, yellow, the one I want. Just be careful, the purple one is much more expensive for some reason because they are not using the same materials for all of the other. And then you can choose the silk screen color also. So for those designs, I only went with red and blue. And then you can have a quote for the PCB. It's not going to be that much expensive, but the expensive part is the shipping, depending on how fast you want to receive the PCB. Okay, so there is a small bonus because if you turn the Shitty Add-On, you can see that I messed up. So I don't know, maybe it's not very. Can you spot the difference? Maybe you can't very see. Maybe on this part. So this one is working. This one is not working.
Oh,
Yeah. that's, yeah, prototype. It's not that bad. I just only print 20 of those. So yeah, they are not working very well, but it's a quick fix, actually. I just have to rotate this one on the other way, because when I added this one on the back, I just like copy paste, and it was the same rotation as the front. So yeah, the plus and the minus are not good. So I need to flip that because on the host name, the host port here, I need to respect that order because the plus and minus are going to be on that exact same place. So if I solder a connector here, it's not going to be powered on because the plus and minus are here. There is a quick fix, kind of. Just solder some wires. It's working. It's working. So if you get one that is not soldered, I'm going to share, there is a QR code behind that's going to be like my link tree, and there is a link to the PCB. I'm going to share maybe next week a tutorial how to solder this one correctly, if you get one that is not soldered, with all the components that you need to solder. But yeah, it's working. And yeah, that's it for this presentation. If you have any question, I'm here. Or maybe later if you catch me also, you can ask you a question. And yeah, I have some Shitty Add-Ons here if you are interested. Make sure to take them. You can plug them into any like DEFCON badge or something like that. They are not working on the Wild West Hacking badge. They don't have the Shitty Add-On connector. But yeah, thank you. No question?
How would you build one of the badges to plug into it? Same process?
For this badge, that's the same process, but much more complicated because you will have, for example, at the screen, microcontroller, batteries. So it's working the same way, but much more complicated. Yeah.
Can you repeat the questions for the virtual folks?
Yeah. If you have any questions. Oh, okay. Repeat the question.
Like
okay.
Yeah.
Yeah. He asked me about how to build an actual badge to host the Shitty Add-on. So yeah, it's much more complicated for that. Yeah. And for now, that's my final goal, to build a badge like this. I'm just learning by building Shitty Add-on for now. So yeah, the final objective is just to build a host badge like this, a cool badge.
Is it custom firmware and everything on the badge?
Yeah. You can build what you want actually with the badge. Yeah. I've seen like a lot of conference building badge, and the best way to avoid e-waste on those is to make sure that the badge, if you are not using it after the conference, maybe make sure that someone is going to use the badge later for something that he wants. So if you add like a Wi-Fi feature, you can people can just build a custom firmware for that and use that badge later. So it's not going to stay in a shelf like forever. So if you add like features and components that's going to be useful for someone, yeah, just make sure that it's going to be the case. No more question?
Simple one. Is there in KiCad a difference between on the schematic surface mount and through-hole components, or?
So yeah, he asked me about the difference about surface mount and through-hole on KiCad. No, it's going to be the same. Maybe the PCB editor will be different from the component parts, but it's going to be the same process. Yeah. Yeah.
So this is my first hacking convention.
Okay.
Do you make your own custom badge, or is this something that you've acquired from another conference?
If I make a custom
Do you
badge?
make your own badge?
If I make my own badge, no, I'm learning to make my own badge. So by learning, I'm building Shitty Add-on for now. So yeah, the Shitty Add-on, like I said, are much more easier. But yeah, if you want to build a a full badge like this, yeah, you will spend much more time, and because you have much more components that needs to work together, then you have a firmware to actually program to make it everything works. So yeah, that's my next step, but yeah, baby steps.
That's a hell of a watch. Oh yeah, I felt that too.
Yeah.
Someone's behind me shaking their leg.
I'm hoping there's laundry nearby.
What? Yeah, thank you. Oh, the floor, I don't feel it here.
I'll reach out to you. I've got some questions. But thank you.
Okay, yeah, thank you.
Just a side note, since you're interested in learning more, if you check into some of the ham radio clubs, a lot of people are building their own radios and
Okay.
various components. And
Oh,
the
nice.
process you're talking about is one of the guys in my ham club does, and he actually gave a presentation on it.
Okay, yeah, I'm going to check that. Yeah, thank you.
It's not Shitty Add-On, but we made one for our company.
Oh,
that's
yeah.
like a stand-on-
I have it
already.
here.
All right, so
Thank you. Thank you. Well, no more question. Thank you, everybody. Thank you.